much. Okay. First, thank you so much for having me here. This will be a pretty different presentation compared to the previous one we had because it's under a sociological perspective. So basically, let me introduce the context first. So we are speaking about the hiring process and about automating hiring. So basically, as we already said before this morning with the previous presentations, hiring decisions are really influential for people because they determine key aspects of their lives, as for example, the possibility to have a good income for growing a family or for receiving high quality medical help. So hiring decisions are a huge burden for employers because they feel pressures in two ways. First, they need to make high quality hires for organizations because firms want good people to work for them. And second, they need to make lawful hires for workers, trying to don't discriminate people. So what happens is that employers search for tools that can make these hiring decisions easier for them and to support their decision process. So among the many tools they are using, one that is increasingly used by organizations is artificial intelligence algorithm. So basically, what do? Employers use this algorithm for screening worker CVs. So basically, they receive job applications, they bring the CVs, they give them to the machine, feeding the machine with the CVs, and algorithms need to predict what is the expected future performance of the worker if the worker is hired. So this is an automating hiring process, and it's really important because it has a direct impact on workers and job applicants, mainly in two ways. The first one is the fact that algorithms define who is hired and who is not. Think about the fact that 72% of CVs, this was in 2019, so this is a growing percentage, they are never seen by human eyes. So we are in the end of algorithm. And second, they can reproduce existing biases that are already affecting current hiring practices. We already saw this morning with the previous presentations that this is an issue that it's really well recognized by the existing literature. So what happens is that given that employers use this algorithm for hiring workers, algorithms are programmed in a way that follow the target imposed by employers and employers' preferences. So what can be the result are implicitly biased predictions. Why does this happen? Because employers' gender cultural stereotypes, like for example, you are a woman, you have a child, you need to stay home caring for your child, they explain a lot the majority of the persisting underrepresentation of women in high-profile jobs. Managers are not women. And what happens is that algorithms, because need to follow employers' preferences, target workers based on these cultural stereotypes. So for example, they can impose a motherhood penalty to young women. And this will come back in my hypothesis. So what we know from the literature is that algorithms are replacing humans. They are used in the first stage of the hiring process before the worker is interviewed. And we know that there are several problems concerning their application in the labor market. So the main concern is related to algorithmic fairness. And the literature focuses a lot on bias training data and on the calibration and programmation of algorithms according to employers' preferences. The literature proposes a lot of framework. I'm speaking about the sociological labor market literature and economic literature mainly. They propose a framework for addressing these challenges. And the only empirical research existing, so really going deeply studying this algorithmic bias, provides evidence of bias training data as a source of algorithmic bias predictions, but no correlation at all with between bias predictions and coders' gender. So no matter whether the coder, the programmer, is a female or a male engineer, but the predictions are still discriminating women. What we don't know, however, even if the existing literature does a really masterful job in developing data processing strategies to tackle this issue of algorithmic bias, is that the causal origin of this bias. Only few authors ask why this bias got into algorithm in the first place. And there is no empirical research really studying the causal source of gender differences in algorithmic predictions, of course. However, to know this causal origin of bias is fundamental to know what is the true and actual impact of algorithm in hiring. Ooh, doesn't work. Okay. So what I try to do is to fill this gap, asking whether, and above all, how algorithms may discriminate women, so may discriminate based on gender. Yeah. Okay. How will I answer to this question? So I do a benchmark experiment. So I compare a supervised learning algorithm, the popular ones used by companies when hiring, in terms of accuracy and biasness. So accuracy means how well the algorithm predicts the true value, the true expected future performance of workers when hired. And biasness means whether this error, the prediction, is strongly correlating only to gender. It depends only on gender, and it doesn't depend on other factors. I will use a panel data set on Italian workers' histories that covers a time span from 1988 to 2004. And my strategy follows 3 steps. The first one is to assess algorithmic fairness. The second one is to understand the drivers of algorithmic unfairness if I detect it. And the third one is to understand the mechanism through which this unfairness comes into place. So to assess algorithmic fairness, a definition is needed, of course. And existing literature does not have yet a single definition of algorithmic fairness. Furthermore, there is no harmony among the existing definitions. These definitions of algorithmic fairness are not compatible among themselves, and it's impossible that algorithms are able to fulfill all the requirements that all the definitions impose. So a choice is needed here. And what I will use as definition of algorithmic fairness are 2 definitions that received much attention from the literature, which is the equalized odds definition that states that algorithms are fair if they are able to predict the true outcome for both men and women. And the second one is group conditioned accuracy. That means that if they have a margin of error in their estimates, this is the same for men and women. Why this choice? Because this resembles a lot the aim of employers during the hiring process. They use this algorithm to know something that they could not know without artificial intelligence, which is the expected success of workers if they hire them. So what they want is algorithm to predict this outcome in the best way possible. And the outcome I'm using, what I want algorithm to predict is the expected worker's future performance when hired. So basically, I use the information on worker CVs, so job qualifications during their work career, job tenure, whether they obtain promotions, and the length of job contract, to make algorithm predict a variable that is impossible to know before the worker is actually hired. So what I expect based on the literature is first that if the training data is not biased, algorithm will predict accurately and unbiasedly the expected worker's performance. This is related to the previous literature. It's not working, right? No worries. The previous literature I showed you before. And second, if algorithm predictions are gender biased, this could be explained by a motherhood penalty attached to women, so related to gender cultural stereotypes of employers. So this is the performance of, the graphs came out quite small, but so this is the performance in the raw data of men and women, the data I feed the algorithm with. So basically, if you look at the right side, you see the difference between the probability of performing well when hired between men and women. Women are the pink bar. And we see that on average, women have a higher probability of future success when hired compared to men. Thank you so much. And this probability is not due to sectoral composition of the Italian labor market. It's shown on in this figure. Ooh, I lost. Okay, here it is. Okay. These are instead algorithm predictions. So this is accuracy. So basically what you see in the averages is the average error for men and women. Men are here and women are here, of algorithm predictions. We can see that for women, algorithms have a higher error. So basically, they find it harder to predict the future performance when hired for women rather than for men. So under the group condition accuracy definition of fairness, algorithms are gender biased. They disadvantage women. But the most important result is this one. I show you just two graphs because all algorithms have the same prediction, because I can tell you that later if you have questions because of time constraints. But basically, as you can see, the bars present the same estimate. So on average, algorithms predict the same probability to be successful for men and women when hired. Trust me, you cannot see the numbers, but the algorithms underestimate women performance. They do not recognize their advantage. To check that this result is not driven by how I programmed the algorithm, I performed the same analysis on a simulated data set. And actually what happens is that algorithm truly captures this difference. I don't have the graph in the presentation because I want to keep it shorter, but we can discuss about it. It's in the paper. So under both definitions of fairness, algorithms are unfair. They present gender bias that disadvantages women. So to understand the drivers, I perform the analysis unpacking the performance measure. So I divided it between commitment to the job and suitability to high-profile jobs to see whether something changes. And what I found out is that actually algorithms are biased against women only when in the true data, so in the raw data set, women are in an advantageous position compared to men. Otherwise, algorithms make an unbiased mean estimate However, still finding it harder to predict performance for women. So the value that employers receive about the probability that workers should be hired is the same for men and women, especially when women perform better than men. This is a huge gender bias. In order to see why this could happen, I tried to test a model penalty mechanism. So from this graph, you can see that the probability to take maternity leave in the data set I'm giving the algorithm is increasing in age until women reach 35 years, and then it decreases. So I performed the same analysis with women and with childbearing potential and women without childbearing potential. So the green bar shows the true value of women's success if they are younger than 35 years, so they have childbearing potential. They perform better than older women. But algorithms do not recognize this advantage. So what can help explain this bias I found in algorithm is the fact that actually they are truly applying a motherhood penalty to young women. This is not, of course, the only mechanism explaining these results, but this is one hint to help understand what is happening when algorithms are actually used by companies. So to conclude, what I've done is to try to understand what happens when algorithms are applied to the hiring process, because they have a direct impact on job applicants, determining whether they can be hired or not, and reproducing existing structural biases already dominating the hiring process. And what I found out is that algorithms can be gender biased, disadvantages women, and this result can be interpreted by a well-established mechanism in the literature, which is the fact that algorithms can assign a motherhood penalty to young women, which drives down the estimate of their expected success when hired, advantaging men. And this is really important because it follows what has been said this morning, that algorithm can use some variables as proxies. So in this case, even if we drop out gender from the CV, so we delete the name of the applicant, for example, yet we can have biased predictions because it is enough that we have the age of the applicant and whether the applicant ever was in maternity leave. Because especially in Italy, we have still it is still more common for women to take maternity leave compared to men. Paternity leave, of course. Indeed, my study has a lot of limitations, and especially the specificity of the setting, because I'm speaking about the Italian labor market, and also I'm using a panel data set on Italian work histories. Maybe with a different data structure, results could be challenging, and also other definitions of fairness could challenge my results. But I think that this study also contributes in fostering generalization because parallels may be drawn with similar or also different scenarios. And the most important thing is that more and more human activities are being replaced by artificial intelligence algorithms. So this study can help us understand the implications of the micro-level tendency of automating decision-making processes in the context of the labor market. So thank you so much.
Thank you, Elena. It's been really, really interesting. Does anyone have a question? In the room? I cannot see.
If not, I have one question.
Of course.
I am the official questioner here. So a question. So very quickly, what would you say about the because one thing that you have tried to explain is why did this happen, and that's really interesting. So one traditional idea is that in labor market, this problem, at least theoretically, should be solved by market itself, because employers have a big interest in trying to employ the best possible candidates, as you already explained. So why is that happening? And what do you think about this idea that normally in this particular field, the problem is not to be, is theoretically has not to be so important, because market will try to fix it. So that would be my question, and then we have another.
Should I answer before I forget the question? Okay.
Well, first of all, thank you for your presentation. And sorry if my English is not the best, but I'll try to do my best. My question to you is, what do you think would be the best way to improve the algorithm to prevent these type of violations that you said that could occur in the job or for the job applicants?
Okay, thank you so much. They are both important and interesting questions. Like in the first case, of course, employers want to hire the best worker, the most productive, the most efficient, and that's why they are using algorithms. They want efficiency, low costs, and high performance. However, the issue here, especially if we relate the problem with motherhood penalty, is the fact that even if women perform actually better than men, the problem is that if they have a child, they need to stay home. So for employers, it's a trade-off. Like, do I want the perfect worker, even if she will stay home for a couple of months, or do I want a second best worker, but I'm sure that he will stay in my company and I won't have any kind of issues related to maternity? Because there are also studies saying that women that have children are not so committed to the job as men, because they have in mind their private life. And so it's not really a problem that is automatically solved by the market. This would be great if the theory could be applied to this situation. But in this case, performance is a trade-off. Like there are also other studies saying, like investigating the labor market and the hiring process, showing that, for example, employers ask women if they are married, if they are engaged, and they search on Facebook whether the husband or the partner is in a tenured position, so that they can prevent women, like they can forecast whether a woman will change place, will change city, or will stay within the company because she has a husband that is in the city with a tenured position, and she will follow the husband. So it's a tricky issue, but it's not solved as the theory predicts, unfortunately. Yeah, and regarding the second question, there are a lot of strategies that are brought about by the existing literature, especially in computer science. One, okay, I'm not in this strand of research saying, okay, let's drop gender. I think this is wrong, because if we drop gender from algorithm, we cannot calibrate it, and we exacerbate the problem. So the solution is not dropping gender, but keeping gender, keeping maternity, keeping the variables defining women and men, and calibrate again algorithm in a way that we attach more weight to women, for example, if we know that they will be discriminated even if they are in an advantageous position. This is tricky. For example, someone is just calibrating algorithm to predict the same outcome for everyone. But indeed, this discriminates in the reverse situation, like we are discriminating men for advantaging women. So it's not easy to solve the issue, but in my opinion, the best thing to do is recalibrate everything with these problems in mind in order to be sure that we are fair for everyone.
I have a question. The thing is that, do you think that this problem is to be solved recalibrating algorithms rather than changing the police in general? Because if you say that it's not only algorithms that are discriminating, but also people when hiring they discriminate, it's not easier to establish the same paternity and maternity leave period for everybody, or I don't know. Not sure if you.
Yes, indeed, this would be the best option. Like, because the issue is that the labor market is dominated by discrimination, like historically dominated by discrimination, and we were not able to solve it because the thing is that now employers are using this algorithm as a further weapon for discriminating women and minority groups again.
Impartial.
Exactly, because they can say, yes, it's the algorithm, it's not me. Like, algorithms are objective, aren't them? They are machines. But it would be the best thing to find legal tools or policies that solve these issues from the bottom, like from the starting point.